Geometry geniuses, back again. We are going to be taking down the midpoint and bisector of a segment. In the previous segment, we saw that we could add segments together. So if we had a segment from A to B, and we were adding segment B to C, we could say that this is equal to segment AC, just adding it all together. Notice the pattern where the endpoints are the same, even though these are different segments. AB and BC are not the same. So the midpoint sounds just as if you are picturing it. It's the middle bit of a segment that divides a segment into two congruent segments. We call the point, line, or ray, or some other segment that intersects the segment at its midpoint as the segment bisector. So it splits the segment into two parts. Think of bi like a bicycle. There are two wheels. I guess you could say that they're congruent. They're not the same wheel. This is a terrible bike. But you know, with the bicycle, you have two wheels that are the same. So that piece that splits the segment into half at the midpoint is called the segment bisector. This visual bit here should help. So what can we say? We can say, using the midpoint definition, in this example, U is the midpoint of T to V. We're finding T to U, U to V, and T to V. Cool. All right, so we know that U is the midpoint. And it's considered the segment bisector. This allows us to say that, well, what does this say? If U is the midpoint or the segment bisector, what can we say about the other segments in here? We could say that from T to U, is congruent to U to V. That's fair. All right, so this also allows us to say that the segments, segment lengths, 8x plus 11 is equal to 12x minus 1. That's fair game. If we solve this using a little bit of algebra, it's going to say that 12 equals 4x, so x equals 3. But does this solve our issue? Da-na-na-na. So T to U, we can go back, we can plug in for x. This is going to be 8 times 3, adding on 11. So that's going to be 35, staying alive. And U to V, well, that's going to have to be the same thing, even though that work to get there is a little different. 12 times 3 is 36, deduct 1, that's 35. So what's T to V going to be collectively? Well, let's think this out. If this is 35, this is also 35, 35, 35, 70. Cool. We come back to the original puzzle at the beginning, where if we are talking about the clock, using the diagram below, we'll actually reveal the answer to that puzzle at the beginning. The points indicate the chimes and the coordinates represent the time in seconds. So what's the coordinate of B? If B is halfway between, what do you think? Well, ideally, if 3 is out here, 0 is here, the midpoint between 0 and 3 is going to be 1.5. 1.5, and why is that? Well, B is the, what's that vocab word again? Do you remember it from the beginning? B is the midpoint of A to C. What are the coordinates continuing from D, E, and F? Well, if we continue this pattern of 0 plus 1.5 plus 1.5, let's see what happens. So notice this pattern of just adding 1.5, adding 1.5, 3 and 1.5. It's going to say that D is going to be 4.5. So this is 4.5 actually, which actually makes E what number? 6. And then for 6 o'clock itself, that actually makes it an additional 1.5, so 7.5. So that's interesting. Look at this off. Well, I wouldn't say off. I mean, remember, we were trying to get to 6 o'clock. Originally, we said it was 6, but now it's saying 7.5. So the answer is that it takes 7.5 seconds, which is interesting. Because we assume that from 3 o'clock to 6 o'clock is just going to be twice as much. But as we see here, breaking this down as a segment, that's what we're going to get. Thanks for watching. We'll see more of this in the next section.